Hello guys, welcome back to my channel, Memo African Motives. Still working on the question paper which was written in February 2022. We are now on question 2 for mathematics N4. So we shall just have a continuation, guys, and see how we are supposed to answer this question. So if you're new, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. So the first question that we are given there on question 2, which is on integration. As you can see, everything is on integration. We are asked to evaluate the integral of, so this is the integral of, that sign represents the integral of, this is revisions, and I hope all these signs, they are now understood their meaning. So this one is e to the exponent of half x, which is the exponential there, minus 2 with respect to x. So this dx is with respect to x. All right, so we are working with the e in this case here, of which we can actually use this concept. There are actually two ways that we can find this integral. Let me just write down. If I am to find the integral of e to the exponent of f of x like this, dx, which is with respect to x, I can actually use this formula, e to the exponent of f of x over the first derivative of f of x plus the constant of integration. That is the concept that we can actually use in this case. So what does this mean? This is e to the exponent of f of x, which is this part here. This is your f of x here, this part with x. So this part, on the first part, it has to remain as it is, which is going to give us e to the exponent of half x minus 2 like this. Everything over the integral now of f of x, which is this part here. Our f of x is equivalent to half x minus 2. So what is the derivative here? So as you can see, this is going to give us a half from half x here. We're going to obtain half, and this is a constant which is a 0 there. So which means you're going to obtain half from your derivatives. So that is everything over a half like this. All right, of which someone can rewrite this. Remember, you'll be having the constant of integration, but whenever you are given limits like this, the constant of integration does not matter. Why? Because definitely it's going to cancel with another there, so you can just leave it like that. It doesn't matter. Okay, then also here, this means 1 divided by 1 over 2, this part, because there's a 1 there. So you can actually simplify that. So what do I mean? This part here, it's simply 1 over 1 over 2 like this, which is going to give us 2. So that means someone can rewrite this as 2e to the exponent of half x minus 2 like this, with the limits 1 and minus 1. That is what you can do, or you can just leave it like this. It's still fine, or you can leave it like this. Remember, your constant of integration, like I said, you can write it, or you can just leave it like that. It's not a matter, this one, when there are limits. So now we can substitute the limits now. If you are using this c, you are going to substitute in place of x here. You substitute a 1, that's 2e. If you substitute 1 here, it's going to be half by 1 like this. As you can see, this is just a half, so it's going to remain as a half minus 2 plus the constant of integration. That is when you use this, but if you didn't use this, then it doesn't matter, just leave it like that. Minus, you substitute the lower limit. Remember, it's all about the upper limit minus the lower limit. All right, so our lower limit is -1. So in place of x, we have to substitute -1. So as you can see, half times -1, that's a -half. So it's going to be 2e to the exponent of a negative half like this, negative 2, and we close the bracket there. So if you use the constant of integration, then you just write plus c. So as you can see, c minus c, that's s0 there. So you'll be just left with this part of 2 e to the exponent of half minus 2 minus 2 e to the exponent of minus half minus 2. So that means we have to use the calculator properly. Take note, guys, the exponent there should be taken here. This e here is taken here, as you can see from, I don't know if it is going to be clear, it may be here. This here, shift e, you can see there's an exponent there, so that is what you do. So in this case there is 2, then you shift e, that is a half like this, minus 2. Okay, then you move on aside, minus 2, shift e again to the exponent of minus a half minus 2, like that. So you can actually use your calculator. You can actually use your calculator at once, but this part, I hope most of us, we are used to this, guys. So we are obtaining 0.282 something like that. All right, so if you can round off to 3 decimal places, it can be 0.282. So that is the integral of what we were given there. So as you can see, guys, maybe you wanted to apply from your formula sheet here. There is this formula here. Maybe you wanted to apply it. Yes, you can do that. But take note, when you are applying this integration, this concept, maybe you wanted to apply that concept, what it was going to look like. I just want you to see this part here. Maybe you wanted to use this. It was of x minus 2 like this, dx. So what you're going to do, this is ka, this a is our e, this one, our a here is this e, okay? But here there is x. If you are given, let's just say it was ka to the exponent of mx like that, the answer was not going to remain like this. It was going to be ka to the exponent of mx like this over m ln a like this. So actually this m is representing the derivative of this. So if it is f of x, then this is the first derivative of x like this. So that is what you can. So this, from your formula sheet, you are not given something that is direct. You are supposed to work out from the formula, from your formula sheet. This formula does not apply direct. You have to work it out to find the integral that you're given. Okay, so this is going to be our final formula from this one, which is, this is going to remain as it is, which is a to the exponent of half x minus 2. As we can see here, it remained as it is, our a here, ln a, but with the first derivative now. So we are going to find the first derivative of this, which is half. Ln a, our a in this case is this one, so it's going to give us ln e. But we all know that ln e is equal to 1. So if ln e is equal to 1, that means this is simply half times 1, which is a half. So you are going back to the same thing that we used, or that we determined here, using this easier formula to just say the integral of e is simply e to the exponent of f of x as it is over the first derivative of x. You are done. So that is your integration there. So, and then you apply your limits after that. So let's see, guys, the other question that we were given here. All right, so the second question is simplify and integrate. Simplify and integrate. All right, so here I just want us to work it out. Remember, when you are given to simplify, which means there's something that you're supposed to do first before integrating. So to simplify is to rewrite this whole expression in a format or in a way that you can integrate. So here we can't integrate direct because there's a bracket there. Take note, guys, there's a bracket there, as you can see. So we have to expand this bracket inside. So this is going to multiply inside the bracket. So it's before you integrate. So it's x squared times this because it's outside of the bracket. So it will be like this, x squared by x to the exponent of minus 1 over 3 with this one, which is outside of the bracket. So as you can see, we are back to your laws of exponents, where you know that whenever you are multiplying the bases which are the same, you add the exponent. So it's 2 plus minus 1, which is going to give us x to the exponent of 5 over 3. So that means I can now rewrite this integral aside like this is 2.2. So it's now the integral of this part that we obtained here now as a single, which is x to the exponent of 5 over 3. All right, we move on to another term. Okay, let's move on here because the bracket is going to multiply this. So it's minus 5 over x by x to the exponent of minus 3. This one, because it's outside of the bracket, so it multiplies every term. So as you can see, we have to rewrite this over x from your laws of exponents is same as minus 5x to the exponent of negative 1 by x to the exponent of minus a third. That is from your N3 mathematics, guys. Then you are multiplying the bases here, which are the same, so you have to add the exponents. So that is going to give us minus 5x to the exponent of minus 4 over 3. If you add these two numbers, you're going to obtain minus 4 over 3. So this is what you're going to write now. So we have minus 5 x to the exponent of minus 4 over 3. So take note, we haven't started integrating. We are just simplifying in a format that we can use to integrate. All right, so let's see the next term. All right, so this bracket we are done. Okay, this one is fine. These ones, you just write them as they are. They are fine, those ones. So you just rewrite as they are. That's 2 sec squared x plus 5 sine 3x like this minus 6 over x. So all these ones, they are fine. There is nothing wrong with these ones like this. Okay, so we just needed to simplify this first bracket first. That is why we have to simplify it. Then now let's integrate, guys. I hope everything is clear. Now we can integrate. Okay, so how do we integrate x to the exponent of 5 over 3? Remember, guys, the integral of x to the exponent of 5 over 3 from your laws of integration, you have to add the exponent here. You add 1, x to the exponent of 5 over 3 plus 1 like this over 5 over 3 plus 1, of which if you add this 5 over 3 plus 1 is going to give us 8 over 3. So it will be 8x to the exponent of 8 over 3 like this over 8 over 3 like this. But take note, guys, we can't write a fraction like this with 3 denominators, with the 3 parts 1, 2, 3. A fraction is just supposed to have the numerator and the denominator. So what are you going to do? You divide this because here is same as there is a 1 here. So it's 1 divided by this 8 over 3. So 1 divided by 8 over 3 is going to give you 3 over 8. But remember, there is x to the exponent of 8 over 3, which was there. So that means this whole part that we had can be rewritten as a normal fraction like this, which is 3 over 8. That is what we obtained, x to the exponent of 8 over 3. All right, so all these stages, they don't even show you in your memorandum. That is in your memo. They don't even show you all these stages. They just give you this stage and they give you this stage. But take note, guys, you obtained all these stages through a certain process. That is the idea there. All right. So let's see the other part. Okay, the other part is this one. Minus 5x to the exponent of minus 4 over 3. This one. How are we going to integrate it? All right, let's just write it aside. So using the same concept, guys, remember we have to add the exponent of 1 there. Okay, so if we add 1 to minus 4 over 3 like this, if we add 1, this one is going to give us minus 1 over 3 if you add 1 here, because you're going to add 1, so it's going to give us minus 1 over 3. So it's going to be to the exponent of minus 1 over 3 like this, over the exponent that you now have, which is minus 1 over 3. So take note, the new exponent that you're now having is the one that you divide with. So now there is a number here which is 5, this one. So if you divide this negative 5 with negative 1 over 3 in a bracket like this on your calculator, you are going to obtain positive 15. But take note, there was already x to the exponent of minus 1 over 3. So this is going to give us plus. It's now a plus now. So it's plus 15x to the exponent of minus 1 over 3, like that. All right. We move on to this 2 sec squared. So there we are not going to even think much there, because we have it. Remember, integration is the opposite of what? Of differentiation. Integration, whenever you are given to integrate, is the opposite of derivative. So as you can see, when you found the derivative of tan, it gave you sec squared. So integration is the reverse. So if it is the reverse, it means the integral of sec squared is going to give us tan. All right, so here we are given 2 sec squared, so it's going to be 2 tan x. That is the integral of what? Of sec. All right, we have got sine here. Sine is there. Okay, so this one for sine is there. But take note, guys, like I always say, these integrals are just given so that you can do adjustments. This is sine x, which is going to give us negative cos x plus c. But here, this is sine 3x. Take note. So you divide this derivative, this integral, by, it was supposed to be like this. The integral of sine ax like this dx is equal to minus 1 over a cos ax plus c. This was supposed to be the formula there, but you see that you are not given that formula here. They just give you a sine x. So take note about that. So this is going to give us negative. Take note, there's a negative, but it's going to be this over. Okay, so it's going to be 5 over 3 cos 3x. So it has to change like this, minus 1 over a. So it was supposed to be like minus 1 over 3 times, there is a 5 there. So if it multiplies 5, that is where you just combine it as minus 5 over 3. All right. Then we move on to 6 over x. Okay, this one is also there on your formula sheet. That is the integral of a over x. It's a ln x. So our a in this case is 6. So this one is going to give us 6 ln x. Okay, so we are done, plus the constant of integration. So guys, as we can see, that's how they play around these integrals. That's how they need you to answer. So as you can see, maybe on your formula, on your memo, they just give you this answer. Then you wonder where this answer actually came from. No, these are the actual stages which were behind these answers. Okay, so you're supposed to at least know the basic stages and steps of integration. All right, without wasting time, let us quickly rush to the other part, which is on 2.3 here. On 2.31, we are asked to sketch clearly and indicate the area enclosed by the graph of y is equal to x squared minus 1. The x-axis, take note, between the x-axis, the line x is equal to 1 and x is equal to 2 also indicate the representative strip used to calculate the area. And we've got 4 marks for that, just to sketch this graph, guys. Okay, anyways, let's see how we were supposed to sketch out this graph. And the other thing, whenever you sketch a graph, you are supposed to at least understand the concept of the function that you want to sketch. You're supposed to understand the concept of the function that you are working with. Okay, so this is actually a parabola that we have here, which is a quadratic graph. If this was not there, like, let me indicate what I'm saying here. Sometimes you just need to know the type of function that you're. If this was not there, you were going to have a function like this. It was going to be like this if that was not there. Now, because there is a -1 which was added there, because as you can see, it's not giving us like the normal ax squared plus bx plus c. It's not giving us because this part is not there. So you can just take this as an advantage. All right, so what is going to happen is that it's supposed to have its turning point in the y-axis. When it is like this, its turning point is in the y-axis. All right, so let's sketch. We have to find the x-intercepts. All right, where y is equal to 0. So if y is equal to 0, we need x-intercept. That's y is equal to 0, x squared minus 1. So you can transpose here. That's 1 is equal to x squared. So to find x, that will be the square root of which is plus or minus 1 there. So you've got plus or minus 1. So that means our x can be 1 or our x can be a -1 from this part. All right, anyways, let's move on. We need the y-intercept, so you know that this is when y is equal to 0. So now the y-intercept, that will be on a condition where x is equal to 0. So where x is equal to 0 here, you're going to have 0 squared minus 1. Your y is going to be a -1 from your calculator. 0 squared minus 1, that's -1. So our y-intercept, that is in the negative. Then remember the shape, when it is the positive like this, the shape is supposed to be a smiley shape like this. Everything positive always smiles. Okay, when it is a negative, it's a sad shape like this. Okay, so this one, you're going to take this smiley one. So that is the shape that we are going to have. Okay, so let me just put this way. Let me just put it this way. So you are supposed to do a nicer sketch. All right, you're supposed to do a nicer sketch, but let me just put my sketch here. So the x values is +1 and -1. These are the values in x, which is this x. So you can just put -1 here and +1 here. And the value for y is -1. That is the y-intercept, which is at -1. So let's just say this is our -1. So this is our 0 there, both for y and x. So like we say that the shape is going to be like this. And when this part is not there, the turning point is on the y-axis. All right, so which means your graph is going to be like this. So this is just a sketch, guys, nothing to worry much. All right, so that is going to be someone's function there. That is y is equal to, let's just write even here, no. So there I discovered something, that's why I have to leave this part here alone. But that is what your function was supposed to look like, something like this. All right, now let's listen to the question, guys. Let's listen to the question. The question is further saying we have to indicate some of the points, the y-axis, the lines x is equal to 1, x is equal to 2. All right, the line of x is equal to 1. Okay, remember in this one, the y-axis, we call this line x is equal to 0. So that means all these vertical lines, they represent the equation of x is equal to. So the line of x is equal to 1 is going to be determined here. This is the line here where x is equal to 1. So this is our x is equal to 1, like this. Okay, then x is equal to 2. Let's just say it's somewhere here. All right, let's just say this is our 2. So this will be x is equal to 2. All right, this must join, guys. Okay, this must join. Don't worry. It's because of this sketch, but it must join, so like that. All right, so this is the where we have the position that we are going to find the area. So take note, this area that we have that we want to indicate, it's enclosed, which means it's covered by this graph and the x-axis and these two lines. All right, so it's covered by this graph that we have and these two lines and the x-axis. So which area are we talking about? This is the area here. This is the area here that is enclosed, covered by the graph. Take note, this one is not covered because there is no x-axis here, so you can't talk about this. This one is below this graph here, as you can see, it's not there here. So this one, it's not covered. This one also is not covered because the x-axis is here. So it must be closed by the x-axis. The line of x is equal to 2, x is equal to 1, and the graph. So as you can see, this is the closed shape here. So this is the portion that they are talking about. So the representative strip is going to be like this to the x-axis, perpendicular to the x-axis like this. So let's just say this is our representative strip with respect to x. All right, so that is the sketch and everything that was needed there. So when you're asked to sketch, that's what you actually need to find the x-intercepts, y-intercepts, then you indicate clearly the sketch. Then finally the question is now saying determine by using integration the magnitude of area indicated in question 2.31, which is this one, 2.31 here, because this was going to be used to calculate area with the representative strip. So we know that area is simply means the integral. To integrate is simply to find area. So area simply means the integral of y dx with the limits a and b, where a is the lower limit and b is the upper limit. So in this case, what are we going to integrate? We are going to integrate this part here of y is equal to x squared plus 1. So take note, y is equal to x squared plus 1. So that means our area is going to be in place of y because it must be with respect to x, and something that is with respect to x is this one, which is x squared minus 1. So it's going to be x squared minus 1 like this dx, and the limits a and b, this area is bounded here between 1 and 2. So these are the limits 1 and 2. So 1 is the lower limit, 2 is the upper limit. So that is your area. So area simply means integration, guys. So let's integrate. So our area is going to be, if we integrate this, remember we add 1 here and we divide, so it's 2 plus 1, which is to the exponent of 3 over 3. Remember, guys, the concept of area, x to the exponent of 2 plus 1 over 2 plus 1. Okay, this one is minus 1. So remember, a constant with respect to x is going to give us ax. So this one is going to be minus 1x, but minus 1x is same as minus x with the limits 2 and 1. So like I said, you can write your constant of integration here, but it doesn't matter at all because that one is going to cancel itself. So there's no need for you to write it. Okay, so now you can substitute the upper limit minus the lower limit. So in place of x, everywhere where there is x, you substitute 2. So you put 2 here, you put 2 here in place of x. So it's going to be 2 to the exponent of 3 over 3 minus 2 Okay, so if you wrote this C, then it's going to be plus C, but like I said, this one does not matter at all. Minus, this time the lower limit is 1, so it's 1 to the exponent of 3 over 3 minus 3 plus C. That is when you wrote it. So as you can see, C and C cancels each other. So you are going to be left with this part minus that part there. Okay, so this, I don't know what we are going to actually have at the end, but if you simplify this part alone, this one, you're going to have everything. This one is 2 over 3. That is, if I'm not mistaken, there 2 over 3. This one cancels. Okay, minus here is going to give us minus 2 over 3 on this part here. All right, so this is going to give us minus and minus, that's a plus, so you're going to have 4 over 3 at the end. 4 over 3 square units, or it can be 1,333 square units like this. All right, so that is going to be the area at the end. So the area, guys, simply means the integral. To integrate is to find the area. When you are integrating a certain expression, you are actually determining area because of the limits that you be given, and also the strip that you are going to use, the representative strip that is with respect to x. So that's what we had, guys, from this question. That was question number 2 on integration from the question paper, which was written in February 2022. So as you can see, guys, that's how they ask these questions now. So we need to work on much questions as possible. So that's it, guys, till we meet again.